A dietitian claims that 60% of people are trying to avoid trans fat in their diet. She randomly selects 200 people and found that 128 stated they were trying to avoid trans fats in their diet at alpha equals 0.05. Is there enough evidence to reject the dietitian's claim? What can you identify from that? I'm not making an interval, but you're right, it would be.
Would your p-hat be 60?
Would my what?
P-hat?
Not quite. So the dietitian is claiming 60%, right? The piece that goes in my claim, if we look at the hypotheses above, is it P or P hat? P. So this is my population P for the 60%, so 0.6. 200 is what?
Your N.
My N. What's 128?
Your X.
And then we have our alpha. So I wasn't actually given P hat. Does that bother me? No. Well, it might bother you personally, but we can figure it out. How do we find it? 128 divided by 200. And what's it going to give us? .64. All right. Then what's actually I don't need Q hat. What I do need is Q. If P is equal to 0.6, what's Q equal to? 0.4. 1 minus P, which gives me 0.4. And I should have all my pieces to fill in my z-score. So we've got all the pieces we need. We need to come up with our hypotheses. What's the null hypothesis? What are they claiming? Not quite. The dietitian claims that 60% of people. So P equals 0.6. And if they're claiming that it equals 0.6, what's the alternative? P does not equal 0.6. So we don't know whether it's less or more. We just know it doesn't equal that amount. And then I want to use my P hat to make a decision about that P. So Z equals P hat, so 0.64 minus 0.6, divided by the square root of 0.6 times 0.4 divided by 200. Let's see what that gives us. This one? That's right up above. I just now gave it to you. So you shouldn't remember it from previous things, but just now. I don't want to just build the interval. I want to show the hypothesis test. But yes, you could. It's not negative because I've got 0.64 minus 0.6. Yes. Yes. 1.25? 1.15. Does anyone agree? $1.15. So that's my test statistic. We said alpha is 0.05. This is a two-tailed test, so I need alpha divided by 2, 0.025, in order to get the z alphas, those critical values. What are the critical values that go along with 0.025? 1.96. And since it's two tails, we're going to use both. We'll use the negative version and the positive 1.96. If you fall in the tail with your value, you reject. If you don't, you fail to reject. Well, 1.15 falls in between. So what are we going to say? Fail to reject the null. And what does that tell me about this study? There is insufficient evidence to support. Actually, what are we doing with the claim? We can't reject it, so we are supporting it. So we cannot reject the claim that 60% of people are trying to avoid trans fats. Yes. Yes. Now the divided by 200 is in the square root. No. E is equal to 0.77. What else? N is 80. X is 55. Alpha is 0.01. Now this one is slightly different than what we've had before, only because of the word. We need to build our null and our alternative. Now they're claiming at least 77%. What does the word at least make us think of? Greater than or equal to. But it includes the equal to. So if I have to put an equal sign in my null, I've already encompassed the equal part. So the only thing I have left to test is that it would be less than it. So it's a little bit opposite of what we want, but we're going to say in our alternative it should be less than 77 because greater than or equal to is going to be taken up by the null because the null is already our equal to part. And if you want to think about it, you can say greater than or equal to in there. But I try not to because I want to keep with the thing that we're only putting equal to in the null. So this one's slightly different because of that. Our claim is in the null. And then I can run it like I run any other test. So I can say I need to find my test statistic. And I still only have one sample, so I can use a one prop z-test, or I can use my formulas. And I want to find my z-value and a p-value. So let's see what we're going to get. So I get my test statistic to be negative 1.575, sorry, negative 1.75, and our p-value is 0.0397, 398. So if I put my negative 1.75, the p-value goes in that tail. If I compare it to alpha, what's my decision going to be? I'm greater than it, so I'm going to fail to reject. which means what? There is insufficient evidence to the claims in the null. So since I put insufficient, I'm going to put reject the claim that at least 77% of the population opposes replacing the $1 bill with a $1 coin. Questions on that?
So,
Do you have X and N flipped? Mm-hmm. Mm-hmm. And you have 0.77? No, because you want it to be a proportion. So if it's not a decimal, it doesn't know whether it's a percent or not. Other questions?
Here, n going to be 200 for n1.
N1 is 200. What's 45%? Which P? P what? P hat one? This is my sample. And N2 is? All right. And what's 35%? P hat 2. Because it's also based on a sample of workers. Now, our calculator is going to want X. So how do I find X1 and X2? N times P. So 200 times the 45, 0.45, and 200 times the 0.35. And I heard 90 and 70. Do we all agree? All right, what are my hypotheses? I need a null hypothesis and an alternative. Two samples. So the null is always P1 equals P2. They want to know about, is there a difference? So the alternative is not equal. That's also where the claim is. Gives me a two-tailed test. So we're going to end up with two shaded pieces. And let's see what we get for our Z and our P value. So this time we're going to use the two sample settings. Our two proportion Z int, because we're still dealing with proportions. No, it should be 6. It was right under one sample, or one prop Z test. Sorry, test, not int. I think I said it. But it's a test. X1 was 90, N1 is 200. X2 is 70, N2 is 200. And we are doing a not equals to test. And let's see what we get. So Z equals 2.04. And our P value is 0.041. And we'll compare that to the 0.01. So are we less than or greater than our alpha?